Welcome back to Microeconomics. In this video, we're going to continue talking about comparative advantage, and we're going to do that by talking about how to combine production. So previously, we introduced the idea of two producers, and one of them having the comparative advantage in one good, and we also emphasized that with our two good model and two producers, the other would have the comparative advantage in the other good. We're going to show how this can be used to make production more efficient. Now, by more efficient, I mean producing more with the same amount of limited resources. The resource we're going to focus on is still going to be time. So let's jump in. We're going to continue with this same example of Bert and Ernie producing two goods, duckies and sweaters. And they're both going to be working with this hourly output and working for 8 hours. What are our possibilities for production if they're both working combined? Now, this is actually going to be a slightly trickier problem than it might seem on the outset. But we'll start with the easiest two scenarios. The first is that they are only producing sweaters. If they are only producing sweaters, well, all we need to do is add up the two productions, add up what Bert can do maximum for sweaters and what Ernie can do for maximum. The max Bert can make with 8 hours is 5 times 8 is 40. The max Ernie can make 1 times 8 is 8. So the max that they can make together is 48. This is also if we kind of sum these sweater productions in this table and have the combined production of 6. 6 times 8 is also 48. We can do the same method for figuring out the max in terms of rubber duckies. That's 8 times 4.5, or as we see here, 36. So the naive way about thinking about our combined production would be simply to treat them as we did one person. And we remember with our single person production possibilities curve, we looked at the maximum amounts of each and simply drew that straight line because there was no shift in that opportunity cost. And what is going to be different here is that we're actually going to have a shift. So the naive combination is to simply draw that straight line as we have done before, and our trade-off is 4 to 3, a slope of negative 4/3. Now, let's say that we actually have an order for a number of sweaters. And let's say that there are 30 sweaters ordered, and we spend the remaining time making duckies. So one way to fulfill this order is to work together, each spend 5 hours on sweaters, 3 hours on duckies, and with that we'd have a total output of 13.5 duckies and 30 sweaters. Right? And this is on our naively drawn production possibility frontier, where we are simply treating them as one person working together. But we want to think about, is this the best way to produce? Is this efficient? Can we get more with our limited resources? The answer is going to be no. This is an inefficient way to go about fulfilling this order and making the production. Right? And I'll show you why. We can do better. So in order to efficiently combine production, we have to take into account the strengths of the people producing, Ernie and Bert's comparative strength, or, as we've termed it, their comparative advantage. So this is how we're going to produce more efficiently. Now, the graphical method for doing this, and this will serve you well on exams and quizzes and things like that, is to first start at the endpoints like we have already put in. Right? These endpoints, there's no other way to produce them, and so these are going to be kind of the efficient way to produce all duckies is to have everyone work on duckies. There's no choice we have here. Though we have choices, though, in those middle points of who is going to produce what. Right? And that's where things get tricky. So in order to do this graphically, what I like to do is start at your top left point here, where you're producing nothing but duckies, right? That 48, nothing but sweaters and no duckies, 48 sweaters, no duckies, and then move to the right. Now, as we move to the right, what we're going to be doing is giving up sweaters to get some duckies. Now, there are three main ways that we could do this. We could have both of them, and that was the kind of line that we have drawn, both of them give up some sweaters to make duckies. Or we could have just Ernie give up sweaters and duckies, or we could have just Bert give up sweaters to make duckies, or some combination of between. Now, the principle of comparative advantage tells us that we want to, in order to be efficient, we want to have the person switch to duckies who's giving up the least amount of sweaters to do this. In other words, the person who has comparative advantage in duckies, we should be moving them off of sweater production onto ducky production. This is Ernie. And we can see this actually graphically in terms of Ernie's slope. He has this shallower slope. In other words, he's giving up fewer sweaters to get duckies. And you can see that these points that are on the efficient production possibility frontier were actually not possible when we were moving them both together on this inefficient line here. However, Ernie has limitations. At max, he is making 8 sweaters, right? And giving up those 8 sweaters allow him to make 16 duckies. Right? And so we hit this point where we are completely specialized, where Ernie is completely doing duckies and Bert is completely doing sweaters. And graphically in this setup, that is happening at the point where Bert is making 40 sweaters and Ernie is making 16 duckies. At this point, the only way to get more duckies, since Ernie cannot make any more duckies, he is putting all of his time into duckies, is for Bert to start switching his production from sweaters to duckies. Let's view this graphically. And so this segment is showing Bert's production, where he is giving up 2 sweaters for each ducky. Both of these line segments, Ernie's and Bert's, are their individual production possibilities frontiers. Their Bert's line segment here is this -2 slope, and Ernie's has that -1/2. And what we're doing with the efficient production possibilities frontier is we're putting those together in a strategic way to make production more efficient as possible. Right? This is our efficient production possibilities frontier. Now, to emphasize what this has done versus our naive combination is that before, when we were making these 30 sweaters, we were having both of them give up sweater production to make duckies. But now we're first having Ernie do it, and now having Bert. So here what we're going to do is Bert's going to make 5 duckies with his remaining 2 hours here, and the rest is going to be spent on sweater production, which meets what we were trying to do. Which allows us to still make these 30 sweaters, but instead of just making 13.5, we're making 21 duckies. In other words, using the same amount of resources, that is the same amount of time, we're able to produce 7.5 more duckies. Now, we actually could have used this extra time differently. It's possible that we could have, instead of increasing our ducky production, for other reasons, we could have decided to increase our sweater production. Right? Anything here is on the efficient production possibilities curve, and it is a Pareto improvement versus producing this interior point. So that's our overview of combining production. In the next video, what I'll be talking about is how to think and represent the macroeconomy and growth, and thinking about comparative advantage in that way. I hope you enjoy these videos. Email me if you have questions, and take good care. Bye.